All right, so now we're going to talk about what to do when your trinomials have a leading coefficient that is not 1, anything that's larger than 1. So we don't typically deal with coefficients that are fractions or decimals. They're all whole numbers typically. So now we're going to talk about what to do when those whole numbers are not 1. So first we're going to just observe what happens because we already know how to multiply, and we're going to see if we can find some patterns. So here I have 3x plus 2 and 2x plus 5. So in this box I will get 6x squared, 15x, 4x, and 10. And remember, we're trying to find patterns really for these two middle terms. So these two terms, well, let's go ahead and do the polynomial first. So 6x squared plus 19x plus 10. And before we were doing factors of 10 that add to be 19. So our two middle factors still add to be 19, but instead they multiply to be 60. And that's going to be our pattern here. So they add to be 19, which is still my middle term. That part hasn't changed. But instead of multiplying to 10, these multiply to be 60. And how I can get 60 is I can take A times C. So multiply to be whatever A times C is, add to be B. And I'm getting these letters from our standard form. AX squared plus BX plus C. So we want it to multiply to be whatever A times C is and add to be our middle term, our B, which is the same as it was before. All right, so we're going to do some examples here, so hopefully you can kind of get the hang of it as we go along. This time I have 5x squared minus 14x plus 8. So 5 times 8 gives me 40. So I want factors of 40 that add to be negative 14. Okay, so 10 and 4 come to mind. If they were both negative, that would give me my negative 14 and multiply to be positive 40. So when I'm setting up my box, that's what I want in my diagonal. I want negative 10x and negative 4x because these will multiply to be 40 and add to be negative 14. Now I'm still going to have my original term of 5x squared and 8. And I believe for our last set of notes, you didn't have to use the box method. You could. It is very helpful for this problem type. Last time we just did x minus 10, x minus 4, but that won't work for these. We'll have to actually use the box because what we're going to do to figure out what would be on the outside is take out the greatest common factor. So for this row, 5x squared and negative 10x, the greatest common factor is 5x. And then for this row, negative 4x and 8, the greatest common factor is negative 4. If at all possible, we want our x term to end up positive. So if I have negative 4x, I'm going to pull out a negative 4 instead of a positive 4 so that it ends up being positive on the other side. So when I pull out a greatest common factor here, I'm just going to pull out x because 5x times x is 5x squared. Negative 4 times x is negative 4x. You want it to multiply to be that same thing. So here, 5x times negative 2 would give me negative 10x. Negative 4 times negative 2 is a positive 8. So my final answer here is 5x minus 4 and x minus 2. This, if you multiply it back out, will give us what we started with. Okay, so we don't actually include this 40 anywhere in our box. We're just using that 40 to find our two middle terms. Okay, and if I were to multiply this back out, like I said, I should get what I started with. So moving on to a new example. This time I have 4x squared plus 7x minus 2. So 4 times negative 2 gives me negative 8. So I want factors of negative 8 that add to be 7. So 8 and 1. And it looks like I want my 1 to be negative so that I end up with a positive 7. So these multiply to be negative 8. They add to be 7. So that's what I want my middle terms to be. I want 8x and negative 1x. My first term, I'm just taking from my polynomial would be 4x squared and negative 2. Okay, sometimes people also call this splitting the middle term. We're splitting this 7x into 8x and negative 1x, but this is our polynomial. All we've done is separated that middle term out. At this point, I'm going to pull out my greatest common factor. So for this row, 4x squared and 8x, my greatest common factor is 4x. For this row, my greatest common factor would be negative 1. For this column, my greatest common factor would be x, and if I check, 4x times x is 4x squared, negative 1 times x is negative 1x. And then for this column, my greatest common factor is 2. 4x times 2 is 8x, negative 1 times 2 is negative 2. So I'll have 4x minus 1 and x plus 2. And the order of your binomials doesn't matter. Like I could put my x plus 2 first. You could switch these two sets. All right, new example. This time I have 6x squared plus 17x plus 5. So my first and last term stay the same, but I'm going to figure out how I can split this middle term into two pieces that helps me factor. So 6 times 5 gives me 30. And I'm trying to add 17. So 10 and 3 add to 13, that would not work. 6 and 5 add to 11, that would not work. 15 and 2 do add to 17, so that would work. So I want 15x and 2x. So across this row here, my greatest common factor would be 3x. In this row, there is no common factor I can find, so it's just a 1. For this column, my greatest common factor is 2x. And for this column, my greatest common factor is 5. So we'll have 3x plus 1 and 2x plus 5. And again, if you want to check, you can always multiply them back out. You should get what you started with. All right, one more of this type. This time we have 2x squared minus 7x minus 15. 2 times negative 15 is a negative 30, so we want factors of negative 30 that add to be negative 7. And my first term will be 2x squared, my last term will be negative 15. We're just doing this part to figure out what my two middle terms should be. So 10 and 3 come to mind. If my 10 is negative, my 3 is positive, that will work. So I'm going to put negative 10x and positive 3x here. So for this row, my greatest common factor is 2x. For this row, my greatest common factor is 3. For this column, I just need an x. And for this column, I need negative 5 to make it work. 2x times negative 5 and 3 times negative 5. Okay, so my final answer is 2x plus 3 times x minus 5. All right, now we're going to do one word problem together. This one says, the height of a football that has been thrown or kicked can be described by the expression negative 16t squared plus vt plus h, where t stands for the time in seconds, v is the initial upward velocity, and h is the initial height in feet. Write an expression for the height of a football at time t, where the initial upward velocity is 20 feet per second and height is 6 feet. So we're going to replace v with 20 and height, or h, with 6. So our expression would be negative 16t squared plus 20t plus 6. And then we want to factor our expression. So negative 16 times 6 is negative 96. And then we want it to add to be 20. So I'm going to go ahead and put my negative 16t squared and my 6 here. And then negative 96 that adds to 20. Let's see. All right, 4 and 24 it looks like would work. So we want a positive 24 and a negative 4. All right, so for this top column, I'm going to go ahead and take out that negative 4t, which is going to make this row have a positive 4t. And then that looks like I'll need a 6 to make this one work out. 4t times 6 is 24t. And 6 times 1 would give us 6, and that should work as well. So then I have, for my final answer here, 4t plus 1 times negative 4t plus 6. Okay, so that's part B. We factored the expression. And then it says find the height of a football after 1 second. So we would just plug in 1 for t. So that would be negative 16 plus 20 plus 6 is 4 plus 6, or 10. So 10 feet. After 1 second, it'll be 10 feet in the air. All right, that's it for your notes for today. Now you have a Delta Math assignment.